Hello guys, so in this first lesson we are going to learn about the pandas. So basically what is pandas? Pandas is a Python library used for working with datasets. It has functions for analyzing, cleaning, exploring and manipulating data. The name pandas has a reference from the Python data analysis and was created by Wes McKinney in 2008. Now, one more question which will arise is why use pandas? So pandas allows us to analyze big data and make conclusions based on statistical theories. Pandas can clean messy datasets and make them readable and relevant. Relevant data is very important in data science. So the first thing which we are going to see in pandas is the types of data structures in pandas. So pandas supports mainly three types of data structures. One is series, DataFrames and panel. Series is similar to as 1D labeled homogeneous array, which is like most popular and we are generally habituated of using this type of array. Second, DataFrames, which is the most used data structure in entire data analysis or data science purposes, which is generally a 2D labeled sized mutable tabular structure with potentially heterogeneously typed column. Heterogeneously typed column. This data frame will be seen in the next upcoming few slides and we'll be able to learn more about this particular kind of data structure. And the last one is panel, which is a general 3D label size mutable array. So in pandas, if you want to contain any sort of data that is three-dimensional, a panel becomes a potent contender. It is used less frequently than series or data frames, but it is useful. The term panel data originates from somewhere in econometrics and in a way responsible for naming of the entire library panel data. Don't worry guys, this is beyond our scope, so we will be not focusing more on panel. Now let's see the respective data structures one by one. So first let's start with series. As we all know, series is a one-dimensional array-like structure with homogeneous data. For example, the following series is a collection of integers 10, 23, 56 and so on. It's similarly like an array, but it contains homogeneous data. That is, data of same type. Next is data frame. So as we discussed, data frame is a two-dimensional array with heterogeneous data. That means we don't need to put the same kind of data, but we can have more than one kind of data. That is, for example, both number and alphabets together or strings. An example is shown below. You can see there is a name, age, gender and rating columns which contains rows respectively. First row contains Steve's and his age is 32, gender is male and the rating is 3.45. And similarly, all respective rows are shown. Now in the previous data frame example, if we want to see the data type of each column, we can see it. Like the name column has string data type, age column has integer data type, gender has string data type, and rating has float, which is decimal points. Another point to note about data frame is that a data frame is a two-dimensional data structure, that is, the data is aligned in a tabular fashion in rows and columns. Now, what are the features of data frame? The features of data frames are, first is potentially columns are of different data types, the size is mutable, there is a labeled axis which makes for indexes a little bit easier, and we can even perform arithmetic operations on rows and columns. Perhaps that is the more flexible way of dealing with a data frame. Now you can see the structure here that rows are being specified and the columns are being shown. So in Python, we will be using data frame as pandas.dataframe, and in the arguments we will be passing data, index, columns, t-type and copy. Don't worry, we will see each of the respective arguments in the next slide. This is general format of how a data frame is and what all arguments it takes. Now, accounting into respective arguments, let's see. What is data? Data takes various forms like ND array, series, maps, lists, dicts, constants, and also another data frame. What is index? For the row labels, the index used to be the resulting frame is optional default np.arrange if no index is passed. So basically indexed is just to like number the rows. As in SQL, we used to number the different rows with 1, 2, 3, 4, and in arrays we have generally starting from 0, 1, 2, 3, 4. So basically assigning with each one particular number or anything else to any row is index. So if you don't specify the np.arrange, and it will take the argument as n if it contains n rows as the default index. So it will return 0, 1, 2, 3, 4 and so on. Now what are columns? For column labels, the optional default syntax is np.arrange n. This is only true if no index is passed. Again, as we discussed in index, if nothing is passed, np.arrange n will be the assigned index to the respective columns for the column labels. And the d type, which specifies the data type for each column. And one more beneficial argument is copy, which can be used to copying of data. Like if you want to copy your data set, you can make use of this argument. The general purpose is basically used for copying of data, and if the default is false. So if you want to copy, you need to specify it as true. Now let's see how we can create a data frame. So a Pandas data frame can be created using various inputs like list, dict, series, numpy and arrays, nd arrays, or another data frame. So as we saw in the previous slide, pandas.dataframe. So the argument data can contain one of these. Now we will be deep diving into respective various inputs. You can see here is a general format how you can write data. Don't worry, we will be also working in the code to see how it generally works in practical manner. But the format looks similar like this. First you import pandas as PD, then you pass a data. The data can contain anything like dictionary, list, or even another data frame. Then you call pd.dataframe and you pass on that data argument to it, and you print df, and thus your data frame will get printed. There's another example is shown here, which can be make use of dictionary. In the dictionary, we pass keys and values as the respective arguments. Don't worry, we'll see example of each in the next slide. Now you can see the example here in which we have passed in the data column, we have passed a value key as A and the value is 1, another key as B, another value, and the value assigned to it B. And this series or this dictionary, we had like more dictionary like this. We have another dictionary which had key as A and the value is 5. We have key as B and the value is 10. And we have key C as the value is 20. Now let's see how the data will look like, and let's see in it working in a code manner. Now you can see I have copied the last code from the last slide and have pasted in this Pandas Jupyter notebook. And you can see that for the data, I have passed two dictionaries with the respective keys AB and ABC respectively, and with the assigned values. And when I pass this data in our pd.dataframe and when I print it, the following output is shown. Now as you can see here, since the key C is not being passed in the first dictionary, that's why it has automatically assigned as nan, and while rest is kept as it is. Now let me copy the code for the second example. Now in the second example, you can see I have passed additional argument as index. In the first example, we didn't pass index, so the default was np.arrange, and the value amount of rows we passed was 2. So the np.arrange took the value as 2 and it is assigned. The output is 0 and 1, so it is shown in the first example. But in the second example, we have even generally specified that the first index should be as first and second. Now when I run this code, you can see the index value has been changed as first and second respectively. Now what if I want to have only two columns A and B? So what I can do, I can pass on additional parameter that we just looked, which is column, and pass the value as only we need A and only we need B column. Now when I press Shift plus Enter, oh, just wait, comma. Now you can see the C column has been removed and the output is shown as in the screen. Now let's look how to create a data frame from dict of series. Now let's take series also into our consideration. So in the dict of series, we will be having key as one value and the respective value which will be assigned to those keys will be a Pandas series. Now let's take example for it also. So let me write t equals to, I'll specify key as 1, the value as ed dot series, and I want the value, let's take 1, 2 or 3. I can specify even index. Now let's take another key 2. The value will be pd dot series. Again the square brackets 1, 2, 3, 4. Let me specify index as well. Equal to square brackets a, b, c and d. Now let me call pd.DataFrame on this. pd.DataFrame. Let me pass d as an argument. Let's print. And now you can see the following outputs, which is contained data frame which was constructed from series of dict of series. So this was all about the basics or the introduction to Pandas, and next we will be going to see how to import data using Pandas, that is read data into Python. Thank you.